Hello my dear dudes and dudettes. In this class we're going to be looking at the question of how can we multiply two matrices together. Now this may look like a fairly simple and elementary matrix. Well, after all, matrices are made up of numbers and we know how to multiply numbers, so what's complicated about it? Well, what's complicated about it is the fact that we're dealing with, in fact, a set of numbers, but a set of numbers which is organized in rows and columns according to a certain structure. And so we want to make sure that this product does something good for this structure. As we're going to see in a minute, we're going to define a definition of a matrix product, which is a little bit weird. It's probably not what you expect unless you have seen it before in high school. Okay? So why are we going to use this strange definition instead of some others that may in fact be a little bit more intuitive, a little bit more normal? Well, quite simply because it is useful. Okay, it's a product that turns out to have a lot of applications and then will tell us a lot both about matrices, about vectors, about linear systems, and about a whole bunch of things that we haven't seen yet. Okay? So it's also a product that is consistent with other vector and matrix operations, therefore it all fits together, and it provides simple and effective methods for solving many problems, both problems we have seen so far and problems that we have not seen yet. Okay? Now, the one thing I would like to bring up at this point is that despite the initial appearance, mathematical methods, all the mathematical stuff that we try to help you learn, are designed for one purpose only, and that is to make problem solving easier. We want to make sure that solving a mathematical problem is as easy and pleasant as going to the beach, and so we try to use the easiest possible way. Sometimes that easiest possible way is not necessarily easy and intuitive, but if it works, that is the best method. Now there are also some other methods which sometimes looked a lot easier. Why don't we use this one? Because it doesn't work. Okay? So there's sometimes some of these methods seem to be the fruit of some crazy scientists, and eventually mathematicians and physicists and all the people who are supposed to use these things just throw them away because they're no good. So let's have a look at how this product is in fact defined, and you see it's not that bad. It's a bit weird, but it's not that complicated. So how are we going to define the product of two matrices? Okay, what we're going to do is we're going to use the dot product of vectors. Remember, we've seen already that matrices and vectors are really inextricable. They are linked to each other. One is the other and the other is the one. So we're going to use dot product of vectors. Okay, so what we're going to do is the following. Given two matrices A and B, their product is defined as follows. By the way, I'm keeping hidden for the moment a little detail of this definition that will become quite apparent once I give it a definition. Alright, so the product of two matrices is defined as follows. The element in position ij of the product is going to be given by the product of the dot product, the regular dot product, of the ith row of A times the jth column of B. And that's one reason why this is also called the row by column product. So we take the ith row of the first matrix, the one on the left, multiply by the jth column of the second matrix, the one on the right, and we get the element in position ij. Now, if you want to be picky and you want to see everything in terms of real numbers, this is what the formula looks like for the ij element. Probably it's going to be a little bit easier if I show you with a very general model of how this works. So let's take two matrices, A, whose elements are all A with some subscripts, and B, whose elements are B's with some subscripts. How are we going to construct this product? Okay, now the product will also be an ordered set of numbers in rows and columns. So what are we going to put in the element which is in the first row, first column? Well, we're going to take the dot product of the first row of the left matrix times the first column of the second matrix. So just do the dot product of those two, and this will give us the element in position 1, 1 of the product. Now, what if we want to get the next element? Well, the next element is still in the first row, but this time it's in the second column. So we're going to take the dot product of the first row of the A matrix times the second column of the B matrix. And then we keep going along the first row. Once we're done that, if we want to compute the element in the second row, first column, Now we need to use the second row of the first matrix and the first column of the second matrix. Again, we take the dot product of those two, and that gives us the element in position 2, 1. As you can see, it's a systematic procedure. It's weird, but it's not complicated. But also it's long and involves lots of operations. So guess what? Even for this one, the most efficient way to do this product in practice is by using a computer program, since otherwise it is quite possible that one of those simple operations will be done incorrectly. Now in class we'll be doing a lot of examples and see how this one works in practice, and we'll discover a lot of little features of this definition, but let's look first at some basic features.